Okay, this is lesson 25, I think. It's about power series, radius of convergence, an interval of convergence. This is what we are going to study. Given a power series, what is the interval of convergence? What is the radius of convergence? And what we are going to study, what we are going to remember is the ratio test. What it say the ratio test? The ratio test say the following thing. Whenever you have a series, if you make the limit when n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n, if this limit is less than 1, the series converge. If it is bigger than 1, the series diverge. And if it's equal 1, it's inconclusive. So we need to do it by hand and see at the point where the limit is 1, what happened in the interval on the end points of the interval of convergence. So let's go to practice how to see first if a power series converge or diverge. A power series is nothing else than this expression, b sub n, x sub n. So it's v0 when n equals 0 to infinity. When n equals 0 is v0 plus v1 by x plus v2 by x squared plus v to the infinity, vn x to the n. And this is a power series centered at x equals 0. And the power series centered at x equals z is v sub n by x minus z to the n, or v0 plus v1 x minus c plus v2 x minus c squared plus v3 x minus c cubed. So is the power series is the Taylor polynomial centered at c, but it's a Taylor polynomial that never ends. You keep adding terms and terms. It's an infinity polynomial. Okay, let's go to do the problem. So this problem say find the radius of convergence of this power series. This is the power series. Always I advise you to write a few terms of the power series. So the power series is the summation from n equals 0 to infinity. A power series never ends. You keep summing of 4x to the n. So when n equal 1 is 4x. When n equal 2 is 4x squared. When n equal 3 is 4x cubed. Oh, I see what is this series. This is the series, is a geometric series. The factor that I have to multiply a1 to obtain a2 is 4x. The factor I have to multiply a2 to get a3 is 4x. So this is a geometric series. And when a geometric series converge? A geometric series converge when the absolute value of r, when 4x is less than 1. And if 4x is less than 1 is because 4x is less than 1 and bigger than minus 1. So the x is smaller than 1/4 and bigger than minus 1/4. Or in other terms, the absolute value of x is smaller than 1/4. So this is the interval of convergence. The interval of convergence is from minus 1/4 to 1/4. What happened at the point 1 and minus 1? well, sorry, at the point 1, 4 and minus 1, 4. It will diverge. Why it will diverge? Because the geometric series does not converge at the endpoints. Only have to be strictly minus 1, 4. So what is the radius of convergence? Well, this series is centered at c equals 0. And the series, this is the 1, this is 1, 4, and this is minus 1, 4, and this is, let's say, minus 1. And the series converge here. So the radius of convergence is the radius that exists from the center of the polynomial. From this, it's a power series centered at 0. So is this radius 1, 4 and 1, 4. For a series can happen 3 things. For a power series can happen 3 things. 1, the series converge at the point x equals z. In this case, the point x equals z is the point 0. It converges at the point 0? Yes. No. 4 by 0? Yes. Sorry. 4 by 0 is 0. 4 by 0 is 0. 4 by 0 is 0. 0 cubed is 0. To what it converges at the point x equals 0? To 0. So there are 3 possibilities for a power series. It converges at the point x equals z. In this case, c is 0. It converges in some interval. In this case, it converges at the 0, and it converges inside this interval. And of course, it diverges here. It diverges here. Diverge outside the interval. Diverge. So we can write like this. Converge if x is strictly smaller than 1, 4 and bigger than minus 1, 4. And diverge if x is smaller than or equal than minus 1, 4, smaller or equal than minus 1, 4 is this region, this one. Or x is bigger than 1, 4, strictly equal or bigger than 1, 4, so this one here. So diverge here and converge in the interval of convergence, this one. Okay, let's go to the next problem. Okay, how we will do this problem? It says find the radius of convergence of the power series. To find the radius of convergence, the first thing that we need to know is it converge or diverge. This series converge or diverge. To know if this series converge or diverge, we can use many tests that we have. The best test when it appears factorials are the ratio tests. So the ratio test will say if this limit, if the limit of a sub n plus 1 divided by a sub n is less than 1, if this L is less than 1, converge. So let's go to do it. What is a sub n plus 1? A sub n plus 1, if this is a sub n, this one is a sub n, so a sub n plus 1 is x raised to the power 2 when you change n plus 1 if you have x to the 2n. And you are asking, this is a sub n. This is a sub n. Who is a sub n plus 1? Is when you change the n by n plus 1. So a sub n plus 1 is x to the 2n, n plus 1. So I change the n by x. So it's x 2n plus 2. So this is a sub n plus 1. But indeed, a sub n is x to the 2n divided by 2n factorial. So we need to do the same thing in the denominator. We change the n plus 1. So it will be 2 multiplied by n plus 1 factorial. So it will be x 2n plus 1 divided by 2n plus 2 factorial. And now, yes. So we do the limit. It will be a sub n plus 1, 2n plus 2, divided by 2n plus 2 factorial, divided by a sub n. A sub n is 2x to the 2n, divided by 2n factorial. So this limit is the limit when 2n plus 2 divided by x 2n is x squared. So it will be x squared divided by 2n plus 2. Let's go to do it. Okay. So it will appear x 2n plus 2 divided by 2n plus 2 factorial. Divide or multiply by 2n factorial divided by x 2n. So this is equal. This term that appears here can be written like x 2n multiplied by x squared divided by 2n plus 2. 2n plus 2 can be written like 2n plus 2 multiplied by 2n minus 1 multiplied by 2n factorial. Now, multiply by 2n factorial divided by x 2n. Now, the 2x 2n will cancel here. The 2n factorial will cancel here. So I will have the limit when n goes to infinity of the expression a sub n plus 1 divided by a sub n. And what I want to find, what is the limit when n approaches to infinity. When n approaches to infinity, okay, now problem 3 say find the radius of convergence of this power series. 2n factorial x raised to the power 2n divided by n factorial. So to find the radius of convergence when it appears n factorials, we use the ratio test. The ratio test say find the limit when n goes to infinity of a sub n plus 1 divided by a sub n. In this limit goes less than 1, the series converge. Converge for certain value of x in a certain interval. In this case, this limit goes to infinity, so the series doesn't converge. The series diverge. Okay. So who is a sub n? Well, a sub n is 2n factorial divided by n factorial is here, multiplied by x to the 2n. Okay. And who is a sub n plus 1? Well, a sub n plus 1, wherever you see an n, you put n plus 1. It's 2 times n plus 1 factorial. Wherever you see an n, you write n plus 1. Whenever you see an n, you write n plus 1. It's 2 times n plus 1. So if you work a little bit, this will be 2 times n plus 1 factorial divided by n plus 1 factorial x raised to the power 2n plus 2, or a sub n plus 1 is equal to n plus 2 factorial divided by n plus 1 factorial x to the 2n plus 2. I might have to do the limit of a sub n plus 1 divided by a sub n. So the limit when n goes to infinity of a sub n plus 1 divided by a sub n in absolute value is equal to a sub n plus 1, 2n plus 2 factorial divided by n plus 1 factorial x 2n plus 2. Divide multiply instead of divide by I flip the a sub n. N factorial divide by 2n factorial x to n. Perfect. Now let's go to work a little bit this thing. 2n plus 2 is 2n, factorial is 2n plus 2, multiplied by 2n plus 2, we would reduce in 1, so it will be 2n plus 1, we reduce again in 1, and it will be 2n factorial. X to the 2n plus 1 is x to the 2n multiplied by x squared. Perfect. Just a moment, when I divide by x to the n, a sub n is here, so the x sub n, the x sub n, x to the a sub n, a sub x, a sub n have the term a to the 2n here, n factorial, 2n factorial, so it will be divide by n plus 1 factorial. N plus 1 factorial is n plus 1 by n factorial. Here will be n factorial, 2n factorial, x to the 2n. And now I can cancel things. N factorial will cancel with this. 2n factorial will cancel with 2n factorial. X to the 2n will cancel with x to the 2n. So I'm limited to make this limit. I'm done. I have to make the limit when s goes to infinity of the absolute value of this. But everything is positive, so we do it later. So it's 2n plus 2 multiplied by 2n plus 1 divide by n plus 1 multiplied by x squared. What is this limit? This limit is equal x squared, the limit when n goes to infinity of this expression. This expression goes in the numerator like n squared, and in the denominator like n. So for sure, this expression will go to infinity. So whatever the x I put here, the x by something that goes to infinity, 3 by infinity multiplied by infinity, will go to the infinity. So this will be bigger than 1. So the series diverge for all x. So we write this series diverge for all x because the limit when s goes to infinity of a sub n plus 1 divided by a sub n is bigger than 1. But there is a point where it will converge, and is in x equals 0. At x equals 0, it will converge. Why? Because if you plug in here x equals 0, if you plug in here and the summation is, if you plug in x equals 0, will converge to where? If you plug in x equals 0, will be 0 raised to the 2n. This is 0. N factorial is 1. N factorial is 1. So when n equals 0 is 0. When x equals 0, the other term, if you write down, let's go to write a few terms of this series to realize. When n equals 0 will be, this series will be, the first term will be equal, the first term. When n equals 0, it will be 2 by 0. 2 by 0 is 0. 0 factorial is 1. 1. When n equals 0, will be 0 factorial is 1. So it will be 1 divided by 1. X to the 2n, x to the 0 is 1. So it's 1. plus the following term. The following term will be, when xn equal 1, it will be 2 factorial. When n equal 1, divide by 1 factorial, x to the n equal 1, x squared. Now n equal 3. When n equal 3 will be 6 factorial divide 3 factorial, n equal 3, divide x to the 6. When x equals 0, all the sum here will be 0. So the sum will converge to 1. As a conclusion, the only point where the series converge is at x equals 0. At x equals 0, converge, and it converges to the number 1. But this is the only point where it will converge. At any other point x, the ratio test has shown that it will diverge. Then the radius of convergence is 0, because it converges only at the point x equals 0. Okay, now let's go to solve the problem number 7. It's find the interval of convergence of the power series x summation from n equals 0 to infinity of x divided by 7 to the n. This is when n equals 0 is 1, x to the 0 is 1, 7 to the 0 is 1, so it's 1 plus x divided by 7 plus x divided by 7 squared plus x divided by 7 cubed, and keep going and never end. What is that? This is a geometric series. The r is x divided by 7. This is the r that you have to multiply the previous term of the series to obtain the new one. If you multiply by x divided by 7 this term, you will obtain this term. So this is a geometric series, and a geometric series converge when r is less than 1. So it means that converge when the absolute value of x divided by 7 is strictly smaller than 1. So it converge when the absolute value of x is divided by 7 is less than 1. So it converge when the x, the absolute value, is less than 7. So it converge when x is smaller than 7 and bigger than minus 7. And this is the interval of convergence. When x equals 7 or x equals minus 7, it will diverge, because the geometric series diverge at the endpoints. So we may do a picture here, a graph. This is the 0, this is the 7, this is minus 7. So the series converge at this interval from minus 7 to 7 and diverge outside the interval. So converge on this interval, diverge outside the interval. This is the solution. Problem 5 say find the interval of convergence of this alternated series, minus 1 to the n, x to the n divided by n. It looks the alternative harmonic series. It looks like when x equal 1, it looks the alternate harmonic series when x equal 1. So we want to know if it will converge for which x. For x equal 1 will converge. So let's go to do it. What we will do? We'll do the ratio test. When the ratio test say that the limit is less than 1, we will find the interval of convergence. So a sub n plus 1 divided by a sub n, you know how to do it. If you do it, you will find that this is the limit when n tends to infinity of 1 multiplied by x. So I need absolute value of x to be smaller than 1, to be the limit less than 1. So for which value of x is less than 1? When x is between 1 and minus 1. When x is between 1 and minus 1, the series converge. Okay, and what happened at x equal 1? At x equal 1, if you plug in the 1, you will have the alternated harmonic series that converge. So at x equal 1, converge. So I will put it equal sign, converge, converge. And when x equal minus 1, will converge or will diverge? When x equal minus 1, the series will be 1 divided by n that diverge. Because when x equal minus 1, the series will be minus 1 to the n. Multiplied by minus 1 to the n, this is 1 divided by n. So this series diverge at x equal minus 1. So the interval of convergence is minus 1, comma 1, close here. Now we are going to solve problem 6, that is exactly the same thing that we have done before. We analyze the ratio, the a sub n plus 1 divided by a sub n. If you do it for this series, and you take the limit when n goes to infinity of a sub n plus 1 divided by a sub n, you will find 1 divided by 9 absolute value of x minus 4, and you have to insist that to converge, these have to be less than 1. Or in other words, x minus 4 have to be less than 9. Or in other words, x have to be smaller than 9 plus 4. 9 plus 4 is 13, and bigger than minus 9 plus 4. Minus 9 plus 4 is 5, minus 5. So x should be between 13 and minus 5. Okay, now what happened at the end point? What happened at 13 and what happened at x equal minus 5? Converge or diverge? Inside this interval, it converge. But at the end point, I don't know what is happening, so we have to do it manually. So we plug in x equal minus 5. If we plug in x equal minus 5 minus 4 is minus 9. Minus 9 to the n is the series is now, the power series is now minus 1, n plus 1 minus 9 to the n divided by n, 9 to the n. And the series is, if you make a little bit of algebra, it would be minus 1 divided by n, because 1 divided by n diverge, minus 1 divided by n also diverge. So at x equal minus 5, diverge. What happened at x equal 13? At x equal 13, 13 minus 4 is 9. So it's 9 raised to the n. So this 9 raised to the n will cancel with this 9 raised to the n and will be the alternated harmonic series that converge. It will be the series minus 1 to n plus 1 divided by n that converge. So at the end, the interval of convergence will be between 5 and 13. In minus 5 diverge, in 13 converge. And the problem is solved. So in problem 7, we do exactly the same technique, the same ratio test. Wherever I see n, I would plug in n plus 1 to find the term a sub n plus 1. I would do the ratio and I will take the limit when n goes to infinity. So when n is n plus 1, it will be 2 times n plus 1, 2 times n plus 1, 2 times n plus 1 is 2n plus 2. So it will appear 2n plus 2, x divided by 3 raised to the power n plus 1, a sub n plus 1, and this is the term a sub n. if you divide, this limit goes to infinity, because the limit is infinity for all x. For any x that you plug in, this is the limit. I like to put it like this. This is equal, let me put it here, this is equal to absolute value of x by the limit of 2n plus 2 multiplied by 2n plus 1 divided by 3. This limit goes to infinity. So for any x that you plug in, x by this number will be infinity. So because the ratio test that say that the limit has to be less than 1 and infinity is greater than 1, the series diverge for all x. But there is one point where it converges, that is at x equals 0. The power series center at x equals 0. So if you plug in 0 here, it will converge. It will converge to what? 2 by 0 is 0. 0 factorial is 1. 0 divided by 3 is 0. 0 to the n is 0. 0. So this is always 0. So it converges at the point x equals 0, and it converges to 0. For any other x, diverge. And why? Because the limit of a sub n plus 1 divided by a sub n is greater than 1 for any x different than 0. Okay. Then the radius of convergence is 0. The radius of convergence is 0. And the series converge for x equals 0, and the value of the series when x equals 0 is also 0. Okay. Problem number 8, I find a power series that has minus 1, 0 at its interval of convergence. It's a tricky problem. The series 2x plus 1 to the n is a geometric series. The series is 2x plus 1, the first term, plus 2x plus 1 squared, plus 2x plus 1 cubed, plus 2x plus 1, etc., etc., etc. to the n. And the ratio test will say that the absolute value of this limit will be, when n goes to infinity, will be 2x plus 1 raised to the n plus 1 power divided by 2x plus 1 raised to the n will be the limit when n goes to infinity of 2x plus 1. And this limit when n goes to infinity is exactly 2x plus 1, because the n is not involved here. So we need 2x plus 1, the absolute value of 2x plus 1, to be smaller than 1, to agree with the ratio test that say that when the limit of a sub n plus 1 divided by a sub n is less than 1, the series converge. Then we have that 2x plus 1 have to be smaller than 1, or in other words, 2x plus 1 have to be smaller than 1 and bigger than minus 1. Or in other words, 2x have to be smaller than 0 and bigger than minus 2. Oh, so the x have to be smaller than 0 and bigger than minus 1. So the interval of convergence of this series is minus 1, 0. The endpoints are excluded because it's a geometric series. How to create a series that converge in another interval? You may think how to do it. This is, let's go to the next. The next problem say, let's f of x will be x minus 1 to the n plus 1, x minus 1 n plus 1, divided by n plus 1. Find the interval of convergence of the function and of the derivative and of the integral. So let's go to do it. As we said in class, when you make the derivative, you may lose endpoints on the convergence, on the interval of convergence. When you do integral, you may gain some endpoints doing the integral. So let's go to do it. So the function is this one. What is the interval of convergence? Okay, let's go to do it. We have to do the limit when n goes to infinity of a sub n of the absolute value of a sub n plus 1. A sub n plus 1 is x minus 1 raised to the power n plus 2. Divide by n plus 1 plus 1, n plus 2. Divide or multiply by a sub n. A sub n is n plus 1 divided by x minus 1, the absolute value of this quantity. So this will be the limit when n goes to infinity of x minus 1 n plus 2 is x is, let's go to right, x minus 1 n plus 1 multiplied by x minus 1 raised to the 1. Divide by n plus 2, n plus 2 multiplied by n plus 1, divided by x minus 1, n plus 1. And now cancellation happen. This will cancel with this. So it will be the limit when n goes to infinity of what? Of x minus 1 that can go out of the limit multiplied by the limit of n plus 1 divided by n plus 2. And n plus 1 divided by n plus 2, the limit when n goes to infinity, this goes to 1. So it will be equal, let's go to put it here, x minus 1 multiplied by the limit when n goes to infinity of n plus 1 divided by n plus 2. And this limit is x minus 1 by the limit when n goes to infinity. We divide numerator and denominator by n, and it will be n divided by n plus 1 divided by n divided by n divided by n plus 2 divided by n. When n goes to infinity, this goes to 0. When n goes to infinity, this goes to 0. When n goes to infinity, n divided by n goes to 1, so the limit is 1. So as a final result, I have x minus 1 multiplied by 1, by the limit, and this should be less than 1. So the absolute value of this has to be less than 1. So x minus 1 less than 1 means that x minus 1 is smaller than 1 and bigger than minus 1. Or in other words, x is smaller than 2 and bigger than 0. So the interval of convergence is the 0 and the 2, but we are not sure about the endpoints. So we need to go to the original power series and plug in the 0 and see what series will be. So the function f of x is minus 1 n plus 1 x minus 1 n plus 1 divided by n plus 1 by n plus 1. Let's go to plugging x equal to. If I plug in x equal to, this series will be minus 1 n plus 1 x equal to will be 2 minus 1 is 1. 1 n plus 1 is 1 divided by n plus 1. This is an alternate harmonic series that converge. So at x equal to will converge. And x equals 0 will be the harmonic series, will be when x equals 0 will be the series, the power series will be minus 1 n plus 1 multiply when x equals 0 is minus 1 n plus 1 divide by n plus 1. So at x equals 0, this is the series at x equals 0. And this is minus 1 n plus 1. Multiply minus 1 n plus 1 multiplied by minus 1 n plus 1 is minus 1 by 2n plus 2. Okay. Sorry, is minus 1, let's go to do it, n plus 1 plus n plus 1, or divide by n plus 1. So it will be minus 1, 2n plus 2. Now, this is an even number for any n. N equal 1 is 2 by 2, 4. N equal 2 is 4 plus 2 is 6. So this is 1. Oh, so this series, when x equals 0, the series is 1 divided by n plus 1. That is the harmonic series that diverge. As a conclusion, the function itself diverge at 0, converge at 2. Now we need to analyze the same analysis for the derivative of the function. In the derivative, we may lose the 2. Well, you can do it, I think. You see, on the derivative, you lose the 2. So it's again doing the same procedure. Let's go to do it. So the function is f of x equal minus 1 n plus 1 x minus 1 n plus 1 divided by n plus 1. What is the derivative? It's the summation. No, it's the summation. What is the derivative of the function? It's the summation of minus 1 n plus 1. So I need to do the derivative respect to the x. So it will be n plus 1 multiplied by x minus 1 raised to the power that it was n plus 1, it was at the power n plus 1 minus 1. So it will be n divided by n plus 1. So the derivative of the function f prime of x equal the summation of minus 1 n plus 1. Now n plus 1 divided by n plus 1 will cancel, of x minus 1 to the n. Now, this derivative will be on the interval 0, 2, will converge, will not lose this convergence. The center, the power series is centered at 1. So the radius of convergence is 1, because is 0 is the 2, the power series is centered at 1, so the radius of convergence is 1. 1 is the radius of convergence. But now we don't know if we lose an end, if we can lose an endpoint. So the original series was converge on the interval 0, 2, 0 open, 2 close. So I want to see if I will lose this point. So when x equal 2, what will happen? 2 minus 1 is 1. 1 to the n is 1. So is the alternated series minus 1 to the n plus 1, it will diverge. So the derivative will be converge on the interval 0, 2. At 2 will not converge, because at 2, as I said before, at 2, when you plug in 2, 2 minus 1 is 1, 1 to the n is 1, it will be the alternative series minus 1, 1, minus 1 plus 1, minus 1 plus 1. The sum will not converge to any number. So this is the integral of the derivative, and please, you do the second derivative. Well, let's go to do it. So have the f prime, let's go to do f second. F second of x will be the summation of -1 n plus 1 multiplied by the derivative of x minus 1 is n x minus 1. No, they ask for the integral, not for the derivative, I think, but well, I'm here, divided by n minus 1, and this for sure, this derivative, this second derivative will converge on the same interval. Well, let's go to do the ratio test to know if the derivative will conserve the interval of convergence 0 to. So I think that also if you do the ratio test, this will be the radius of convergence is 1. This is a center at x equal 1, c equal 1. So the radius of convergence will not be lost, even if I do the third derivative or the fourth derivative. Now we want to do the integral. So you do the integral, and you find that the integral will converge on the closed interval 0, 2. So as you see, you start with the function that converge on the open interval 0, closed interval 2. When you make the integral, you gain an endpoint. When you do the derivative, you lose an endpoint, you lose the 2. Okay, you do this part, please. It's not difficult to do it. Okay, next problem. We see, verify that the interval of convergence is the closed interval of -1 to 1. Okay, what you will do? Well, the ratio test. You will find the ratio test. You will say, what is a sub n plus 1 divided by a sub n by a sub n? Whatever you will find, you know. You will make the limits, and the limit is 1, so it will be the absolute value of x. So you impose that the absolute value of x should be less than 1, strictly less than 1, so the series converge on the interval -1, 1. Now we need to see if at the end point converge or doesn't converge. If you plug in x equal 1, if you plug in will be 1 divided by this converge by the comparison test. What it say the comparison test? It say, to remember you, it say if you have a sub n, a sub n that you want to test it, the a sub n will be n plus 1. And you have v sub n, and you make the limit when n goes to infinity of a sub n divided by v sub n. If v sub n converge, a sub n converge. So we compare this series with 1 divided by n squared, because implicitly when you multiply here, there is 1 divided by n squared, and doing the limit when n goes to infinity of 1 divided by n plus 1 divided by n by 1 divided by n squared is the limit when n goes to infinity of n squared divided by n squared plus n. And this limit when n goes to infinity, if we divide by n squared, is the limit when n goes to infinity of n squared divided by n squared divided by n squared divided by n squared. We divide numerator and denominator by n squared, and when n goes to infinity, this goes to 1, this goes to 1, and the other one goes to 1 divided by n, which is 0, so the limit goes to 1. So what it say, the limit comparison test, is that if the limit is a finite number, whatever it happened to v sub n is happening to a sub n. What is happening to v sub n? That it converge, because 1 divided by n squared by the p series converge. So a sub n converge. So when x equal 1, converge. Now we have to analyze what will happen with the series when x equal -1. When x equal -1, this series, this one, It is minus 1 n plus 1 divided by n multiplied by n plus 1. This is an alternated series that converge. This alternated series converge because a sub n plus 1 is smaller than a sub n. This is why it converges, and because the limit when n goes to infinity of a sub n goes to 0, or this makes an alternated series to converge. These are the two conditions for an alternated series to converge. So finally, the series converges on the closed interval minus 1, 1, and the problem is solved. I'll see you soon. Good luck.